Welcome to Spaceverse, your portal to cosmic adventures. In a groundbreaking revelation that's sending waves through the astronomical community, new evidence from NASA's James Webb Space Telescope has confirmed a long-standing theory. The galactic feeding cycle is very real, and it's more dynamic than ever imagined. After more than a decade of astronomical detective work using a suite of powerful tools, from ground-based observatories to NASA's Chandra X-ray Observatory and the Hubble Space Telescope, scientists have finally uncovered the secret behind one of the universe's most fascinating phenomena: rapid star formation in the Phoenix Cluster. This isn't just any galaxy cluster. Located a staggering 5.8 billion light-years from Earth, the Phoenix Cluster is a gravitationally bound colossus teeming with activity. What makes it truly remarkable is its ability to form stars at a rate much higher than what we see in typical clusters, despite hosting a central supermassive black hole with an astounding 10 billion times the mass of our Sun. Now here's the mystery. In most clusters, such a black hole emits powerful jets of energy, heating surrounding gas and preventing it from cooling down to the point where stars can be born. But the Phoenix Cluster is different. Against all odds, its core seems to defy this rule. Somehow, cold gas is managing to survive, gather, and collapse into stars at breathtaking speeds. Astronomers have long speculated about a complex cycle, a feeding loop where cooling gas falls inward, forms stars, fuels the black hole, and is then reheated and pushed outward again. But direct proof has been elusive until now. Thanks to Webb's powerful mid-infrared capabilities, scientists have finally captured the missing piece. In an image that blends data from Hubble Chandra, the Very Large Array, and now Webb's MIRI spectrograph, we see something extraordinary: streams of cooling plasma spiraling toward the galaxy cluster's center, providing a continuous supply of fuel for star formation. This is more than a pretty picture, it's solid confirmation of the galactic feedback cycle in action. And it's not just happening slowly over billions of years. Webb's sensitivity shows that this process is dynamic, turbulent, and happening now, with massive flows of cold gas and intense starburst shaping the very heart of this enormous cluster. With each discovery, the James Webb Space Telescope continues to redefine our understanding of how galaxies live, evolve, and recycle matter on a cosmic scale. The universe, it turns out, is much more alive than we ever imagined. Deep in the heart of the universe lies a cosmic giant, the Phoenix Cluster, an immense and active galaxy cluster overflowing with superheated gas, bursting with activity. And now, thanks to the power of the James Webb Space Telescope, yielding secrets we've never seen before. Michael McDonald, the program's chief scientist from MIT, paints a vivid picture. He compares the Phoenix Cluster to a ski slope, one where more skiers are going downhill than being carried up by the lift. The slope? That's the process of gas cooling within the cluster. But here's the twist: not all that gas actually finishes its descent. Some get stuck halfway, like skiers piling up mid-slope. And that's where the mystery began. Previous observations with older instruments showed only two types of gas: the extremely hot, blazing at 18 million degrees Fahrenheit, and the bone-chilling cold gas around 18,000 degrees. But something was missing: the in-between. The warm gas that bridges the two extremes. Until now, scientists couldn't pinpoint it. It was as if we were watching a story with its middle chapters torn out. But Webb changed everything. Using the powerful medium-resolution spectrometer aboard Webb's mid-infrared instrument, MIRI, astronomers have, for the first time, captured detailed, two-dimensional spectroscopic data from the Phoenix Cluster's core. And there it was, clear and undeniable: the elusive warm gas, glowing between the extremes, tucked inside cavities surrounded by both searing heat and chilly stillness. This warm gas isn't just a footnote. It's the critical link in understanding how material cools, collapses, and eventually sparks the birth of new stars within the cluster's core. As McDonald explains, earlier research only gave us the bookends, the very hot and the very cold gas. But with Webb, we've now opened the middle of the story, and it's transforming our understanding. This discovery doesn't just unlock secrets about one cluster, it reshapes how we study star formation and the life cycles of galaxies across the cosmos. And all of this, from a ski slope in the stars. In a spectacular collaboration across the electromagnetic spectrum, 3 of NASA's great observatories, the Hubble Space Telescope, the Chandra X-ray Observatory, and the Very Large Array Radio Telescope, joined forces to capture an extraordinary image of one of the universe's most intriguing galaxy clusters, the Phoenix Cluster. Each telescope brought its own unique set of eyes to the scene. From Chandra, we see brilliant violet tones representing scorching hot gas glowing in X-ray wavelengths, temperatures soaring into the tens of millions of degrees. Meanwhile, Hubble's sharp optical vision reveals the galaxies themselves in golden yellow. But it doesn't stop there. Hubble also picks up filaments of cooler gas, those delicate light blue tendrils, sites where new stars are actively forming against all cosmic odds. Then, zooming out further, the Very Large Array Radio Telescope picks up ghostly red jets, evidence of past energetic outbursts from a supermassive black hole lurking at the center of the cluster. These outbursts shape and stir the environment, sculpting the galaxy cluster on colossal scales. But there's more to this story than just a pretty picture. Thanks to the cutting-edge capabilities of the James Webb Space Telescope, astronomers have now detected an unexpected signature in this cosmic cauldron, traces of cooling gas at a staggering 540,000 degrees Fahrenheit. While still incredibly hot by human standards, this is cool enough to begin forming stars in the dense cluster environment, a rare phenomenon in such massive structures. And here's where it gets fascinating. 2 ionized elements, oxygen and neon, are behaving very differently under the same conditions. Oxygen, seen only in ultraviolet, shines 100 times brighter than neon at these temperatures. But neon? Though typically dim, it glows faintly in the infrared. And Webb, with its unparalleled mid-infrared sensitivity, picks it up. As Michael Reif, lead author of the study published in Nature, put it, the neon 6 signature is absolutely booming in Webb's mid-infrared channels, providing astronomers with an unexpected and powerful tool for analyzing galactic ecosystems. With this discovery, the Phoenix Cluster becomes not only an anomaly, but a proving ground. Astronomers can now apply this technique to observe more common galaxy clusters. And while Phoenix remains exceptional, this breakthrough opens a path to understanding how stars may form in the most extreme environments in the universe. So, with one image and many eyes, we peel back yet another layer of the cosmic mystery. This is Spaceverse, where science meets the infinite. Subscribe, like, and turn on notifications so you never miss a glimpse into the cosmos. Until next time, stay curious and keep looking up.